In utility theory, a consumer who consumes two goods, and let the two goods be X and Y. So if utility is a function of the amount of good X consumed and the amount of good Y consumed, what is the total differential of this function? What will be the total differential of this function? Right, right. Yeah.
And then times
dx, yes, yes. Partial derivative of what, though, with respect to y?
U.
Yes, yeah. Partial derivative of u with respect to y, right? Times dy. Thank you, Chris. See, it's just this format. It's always this format right here. And in words, what this is saying is du is the total change in utility. The total change in utility is partial u, partial x. What is that in words, in economic terminology? What do we call that in economic terminology? Partial u, partial x. The marginal utility of x. Okay, it's just the rate of change of utility with respect to x. So you could interpret this if you like. If the change in x is 1, then you can interpret this as being the additional utility from consuming one more unit of x times the change in x. Delta dx might be 1, might be 2. So you have to multiply this marginal utility of x times the change in x. Plus partial u, partial y is marginal utility of good y. Then you multiply that times the change in y. Okay, so all this says in words is the total change in utility, just the marginal utility of good x times the change in x, plus the marginal utility of y times the change in y. And now, there's one thing I should caution you on. For this to be really mathematically correct, it has to be the case that dx and dy are infinitesimally small changes. So you have to be a little bit careful in interpreting this because the dx and the dy are understood to be infinitesimally small changes. Okay. When I talk about it, I often talk about the change in x being 1 or the change in y being 1. But actually, for this to be mathematically correct all the time, dx and dy have to be infinitesimally small changes. Okay. All right. Again, we could talk about indifference curves or ISO utility curves and then derive the slope of the indifference curve, just as we did before. Along an indifference curve, what is the change in utility as you move from one point to another point along an indifference curve? The change in utility is 0. So we could do the same mathematical derivation, and we would get this. dy dx, which is the slope of the indifference curve, is just equal to minus 1 times partial u, partial x over partial u, partial y. Or it's minus 1 times the marginal utility of good x over the marginal utility of good y. Okay. Or oftentimes you called the slope of the indifference curve. What was the term you used for this slope of the indifference curve? Actually, minus 1 times the slope. MRS, a marginal rate of substitution. The marginal rate of substitution of a good x for y is just equal to MUX over MUY. Okay. All right. Okay. So this is one illustration of the concept of a total differential.